Hello, this is chapter 15, exercise number 40. This is an example of a hypothesis test. We'll do the full test, the whole thing from start to finish. So the question is, this wine stinks. It says sulfur compounds cause off odors in wine. So winemakers want to know the odor threshold, the lowest concentration of a compound that the human nose can detect. The odor threshold for dimethyl sulfide, DMS, in trained wine testers is about 25 micrograms per liter of wine. Um, and so right there, I'm already thinking, let's go to a blank page here. 25 micrograms per liter, um, I'm thinking that's probably the null hypothesis there, micrograms per liter. But I'll just put a question mark. Let's read the whole question first, but that's my suspicion so far. All right, let's go back to the question here. All right. Um, the untrained noses of consumers may be less sensitive. However, here are the DMS odor thresholds for 10 untrained students. Okay, right there, 10. That's my sample size. So n equals 10. I'm just making some notes to myself here. All right, as we go. All right, oops, wrong page. Here we go. Okay, so here's the raw data. Here's the nose sensitivities here of these 10 people. So we can see most of them is higher than 25 micrograms per liter, a couple lower here, but I would suspect that probably the sample is indicating that for the untrained noses, their sensitivity is less sensitive, meaning the wine has to be stinkier in order for people to smell it. All right. Now, here's the question. Assume that the odor threshold for untrained noses is normally distributed with sigma equals 7 micrograms per liter. Okay, let's write that down on our paper here. That's going to be an important number. We'll need that for later. 7 micrograms per liter. Okay, let's go back to our question. Now, here's the question. Is there evidence that the mean threshold for untrained tasters is greater than 25 micrograms per liter? So let's take a second look at this question here. The question is always how you know how to write that null and alternate hypothesis. Basically, if the answer is yes, that is your alternate. This is just some rules of thumb here. If the answer is yes to whatever question that you're being asked, that's the alternate. If the question is no, that is the null hypothesis. So in this case, the question was, is there evidence that back to our oops, I did it again. Wrong page. Here we go. Back to our question. Is there evidence that the mean threshold for untrained tasters is greater than 25 micrograms per liter? There is the question, and there is our null and alternate. So let's start from the beginning here. Step 1 in the hypothesis test is write the null and alternate here. Okay, so the null hypothesis is mu equals 25 micrograms per liter. So that's essentially no. The untrained noses are just as good as the trained noses. The alternate is answering yes to the question. The question is there evidence that the mean threshold for untrained tasters is greater than 25? So that means the alternate is mu. Oops, hold on here. I wrote the wrong thing here. I need a greater than symbol. All right, so is there evidence that the mu here, the mean of the untrained noses, is greater than 25 micrograms per liter? All right, now at the same time, after writing that null and alternate, let's go ahead and decide what our alpha is going to be. Remember, alpha is that cutoff point for deciding if you accept or reject that null hypothesis. In this question, it doesn't say what alpha is going to be, so I will just use 0.05 for the alpha. let alpha be 0.05. That's the standard alpha. Okay, that's it for step 1. Now step 2 is get your data. Okay, we got it. There it is, right there. There's the data. We need some summary statistics though. We need n equals 10. What does the sample mean? Well, you can download that data off the textbook's website. I did that. Here's a spreadsheet. This isn't Excel. This is a copycat version of Excel, but it works perfectly good. So here's our data. I'll just use the average command here, equal average of A2 through A11. Okay, so the mean here is 27.4. All right, let's go back here. 27.4 micrograms per liter. And that's all we need for now. If you're curious, you could get the sample standard deviation, but we're already given the population standard deviation in the question, so we'll be using this number right there in a couple of minutes. Okay, all right. So let's pause here for a minute. Let's think about what we think the answer is going to be. So the question is the population mean greater than 25? Well, the sample mean is greater than 25, so that gives us some evidence that the population mean is greater than 25. But our sample here, it's kind of small here. Its sample size is only 10, so there of course will be a certain amount of variation. The crux of this question is this 27.4. How far is that in terms of standard deviations? How far is that 27.4 on a sampling distribution from this 25 right here in the null hypothesis? Or how likely or unlikely is it to get a sample mean this high if that null is true? Okay, so now we move on to step 3.